Hello dear students, in today's session we are going to cover a topic from ray optics. In case of a concave mirror, if the object is at infinity, a parallel beam would be there. In parts, slowly listen to it, infer what I'm trying to say, you will be able to understand. Let's, now for case of convex lens, it was actually pretty simple to understand. So ray can't come from this side, ray has to come from that side, only that, therefore we are calling this point as F2 because ray is coming from that side. You will be able to answer all the questions very easily. Hello dear students, in today's session we are going to cover a topic from ray optics. I'm going to tell you that how you can consider all the possibilities of image formation either by a lens, any kind of lens, convex or concave, or by a mirror, any kind of mirror, convex or concave. All right. So if you have clarity on this, you will be able to imagine that what kind of images a particular optical instrument can give you. All right, and that is needed in addressing many of the questions, especially the MCQ ones in which there are possibilities of getting more than one correct. Sometimes the question says that concave lens cannot form so and so image, or it can form so and so image. How do I answer? How do I judge whether this statement is right or not? To judge this, I should be aware of all the possibilities that arises with a given kind of with a given optical instrument. So we'll learn how to do that in today's session. All right, so that is the topic of the session, and let's begin now. So let's first talk about mirrors. Okay, just a minute, guys. Yep. So we will first talk about mirrors. Okay. So there are few points that we need to keep in mind. What I will teach you today is how you can make a mental video, and when you play that video in your mind, you will be able to see all the possibilities that are there in case of any specific kind of instrument. Okay, so let's first consider mirror. So the points that you need to keep in mind, okay, important points that you need to keep in mind. First point, if image is at infinity, okay, then sorry, not image, object, I'm sorry, this should be object. If object is at infinity, then image is formed in the focal plane, or you can say at focus also. Okay, I'm pretty sure that all of you are aware of it. So let me display the figure, the kind of figure that we would be expecting in this case. So if we have a concave mirror, okay, what we are saying is that I'll draw the figure here. If we have a convex mirror, okay, then what will be the kind of diagram? So in case of a concave mirror, if the object is at infinity, a parallel beam would be there, and then it would converge at focus. And keep in mind that we are dealing with paraxial beam. Okay, and in case of this also, the rays would come like this. Okay, and then they would diverge like this. Okay, so this is the figure corresponding to the first statement that I gave you. Now that is the first thing to keep in mind. Second thing to keep in mind is that object and image meet at 2 points. In case of mirrors, object and image, they meet at 2 points, okay, or 2 locations. They are where do they meet? Center of curvature. Okay, if object is kept at center of curvature, then the image is also formed at center of curvature. That is one thing. And second, they meet at the pole. If the object is at the pole of the mirror, okay, then the image is also at the pole of the mirror. So this is the second point that you need to keep in mind. Third point that you need to keep in mind is related to velocity of the image. So we know that velocity of image parallel to principal axis is given by minus v square by u square into VO parallel. So VI parallel indicates velocity of the image parallel to the principal axis and VO parallel indicates velocity of the object parallel to principal axis. So this result tells us that object and image, they always move in opposite direction because v square by u square is going to be a positive number. All right, so we can always say that image and object always have opposite directions of velocity, okay, when we are discussing motion parallel to principal axis. Okay, so these points are good enough for you to make the mental video that I was saying. I've told you 3 points. When the object is at infinity, image is formed at focal point. In fact, we can write a 4th point as the reverse of the first point. The 4th point would be if object is at focus. Okay, again, this is something that you already know. If object is at focus, okay, image will be at infinity. Okay, so although you know these points, I'm just highlighting them right now because we'll be using them. So we know that object is at infinity, image will be at focus. If object is at focus, image will be at infinity. And object and image, they intersect at 2 points, the center of curvature and the pole of the mirror. And object and image, they always have the opposite velocities. With this, let's begin. Okay, so first we will consider, let's say, concave mirror. Okay, so I will show you how to consider all the possibilities of image formation. Okay, in case of a concave mirror. And to do that, draw the principal axis of the mirror. Let's say this is the principal axis. Okay, let us draw the mirror somewhere here. Okay, let's say this is the mirror. Okay, let's consider this point as the focus, and whatever the distance is at an equal distance, let's consider C. I've tried to, consider these two distances as equal. Of course, I did not measure the distances. Now, my plan is to assume that an object, all right, maybe in the shape of an arrow, an object is traveling from infinity towards the pole and then to the negative side of the axis also. We'll talk about that. Okay, so my plan is to imagine that an object is traveling from minus infinity towards the pole of the mirror, and I want to know correspondingly where the image is going to be. Okay, to do that, let's first draw a line which we will refer to as the object line. So, see, this green line is the line on which the head of the arrow is going to be. Okay, so my object would be here at some point, it would be here at some point, it would be here at some point, and so on. So the green line represents the line on which the head of the object is going to be. And if I think about this green line, like after reflection, what happens to this? It passes through focus, right? It passes through focus. So let me draw the reflected ray. So it would be like this. And we can in fact extend it on the opposite direction also. We might need it. Right now, maybe I can make it as a dotted line. Okay. Right now, I'll try to make it as a dotted line. And to do that, I need to merge. Okay. Appears dotted. Okay. Now, so when the object was at infinity, okay, the image was at focus, it was highly diminished, and it was real. Now, as the object begins to shift towards the mirror, now pay attention, as the object is shifting towards the mirror, which means that it is moving rightwards, okay, the image must travel leftwards. Okay, because object and image have opposite velocity. So if the object is traveling rightward, or let me put it this way, so long as the object is traveling rightward, the image will have to travel leftward. So the image will begin its journey from the focus. The object has started its journey from minus infinity. Object is moving rightward, image will move leftward, and they are slated to meet. Their rendezvous is going to happen at the center of curvature. So that means by the time object travels from minus infinity to the center of curvature, image will travel from focus to the center of curvature. So for all these locations, if I were to draw the image, I will draw the image in the red color, I will draw the object in the yellow color. So corresponding to these locations of the object, the locations of the image would be like this. Do you notice this, everyone? Okay, and by the time object reaches the center of curvature, by that time the image will also reach the center of curvature. So when the object is here, at that very moment the image is here. All right, so the image will be an inverted image, it is going to be a real image, and it will have the same size as that of the object. All right, and now tell me guys, if I ask you that all this while when the object was traveling from minus infinity to C, during this period, who had more speed? Did the object have more speed, or did the image had more speed? So I'm sure you can figure this out, that the object will have more speed because object has covered an infinite distance from minus infinity to center of curvature, and all this while the image traveled from focus to center of curvature only. All right, and keep this in mind, this green line got reflected and became the blue line. So if the object is on the green line, the image has to be on the blue line, and therefore I will keep the head of the arrow on blue line always. Okay, the head of the arrow of the image. Okay, now as object continues its rightward journey, the image must continue its leftward journey. So as object travels from C to F, the image must travel from C to minus infinity. All right, so as object is traveling like this, like this, like this, the image is, correspondingly traveling like this, and you can notice that, the distance will go on increasing. Like the image is becoming faster and faster because by the time object has to reach the focus in that duration, image has to travel an infinite distance to reach from C to minus infinity. Okay, so if we are all good till this point, then comes the next question. When the object reaches focus, the image is also at minus infinity. Now if the object crosses focus, now what? All right, based on what I said, so long as the object is traveling rightward, the image must travel leftward. But image is already at minus infinity. Where does it travel now? We can say that it continues to travel at minus infinity, but no, that is not the case. What happens is, the moment your object crosses the focus, okay, the image must still continue traveling leftward, but this time the image will come from plus infinity and then it will travel leftward. So this is what going. So as soon as you cross the focus, the image would be somewhere here. The image would be somewhere here, okay, at a very large distance. And as the object, I clicked something wrong, I believe. Okay, as the object is traveling from focus to the pole of the mirror, remember their next rendezvous, they are going to meet at the pole. So as the object is traveling from focus to pole, the image must travel from plus infinity to the pole. So the corresponding locations of the image is this, like this, like this, like this, and finally they will meet at the pole. Do you realize this? And notice that this way of thinking is also giving you every information that you need about the image, its orientation, its size, even its speed, whether it is more than object or less than the object, and nature. Everything you are getting to know when you start thinking like this. Okay, so till now we have considered all the possibilities of a real object. Okay, because if the object is lying in front of the mirror, then it's a real object. So for a real object, what we can see right now is that for a real object, we cannot get the image between focus and pole using a concave mirror. So that's how you can use this way of thinking to judge that what you can get and what you can't get. Are you getting this? For example, I also noticed that for a real object, it is possible to get virtual images, and those virtual images will definitely be enlarged as compared to the object. So if I give you a statement that, is it possible to get a virtual and diminished image of a real object using a concave lens? The answer is no. All right. If you were not able to follow my statement, pause the video, go back, listen to it in parts, slowly listen to it, infer what I'm trying to say. You will be able to understand. All right. So like this, you can use this. I don't see an image in this region, but let's continue. Like if I say, okay, my object will continue to travel, all right, which means now I'm ready to consider the virtual case also, the virtual object case also. So let me draw the line, okay, like this, okay. So if I'm ready to consider the virtual object, so the object will continue its journey towards right. The image must also continue its journey towards left. And as you see, as the object travels to infinity, the image must travel to focus, whether it is minus infinity or whether it's plus infinity. If the object is at infinity, the image will be at focus. So as the object is traveling towards infinity, the image will travel towards, you can see it, focus. So what I can judge from here, if the object is virtual, in case of a concave mirror, if the object is virtual, then the image is bound to be real, it is bound to be diminished, and it is bound to be an erect image. So you see that I'm able to judge all this by using this method. You practice this method twice or thrice, and you will find that a mental video is there in your mind now, where you will be able to think of all the possibilities of image formation by a concave mirror in a matter of 2 or 3 seconds. So that's the power of this method. And not only this way of thinking will help you answer a lot of other questions. What do I mean? What do you mean by that, sir? What do I mean by that? This is, let's say I give you a question. Okay, let me show you the power of this method. I give you a question like this, that this is the optical axis, this is a concave mirror. Okay, let's say this is the focus of the mirror, and I kept a strip. This rectangular strip is my object. I want to know what kind of image will I get. Okay, like will I get a rectangular image corresponding to the rectangular shape of the object or what? So what you can do here, you can do it like this. See, if this is my object, so if this ray is the object ray, okay, if this ray, so I know that this ray after reflection will go like this. Okay, I know that. And when the object was at infinity, image is at focus. When the object has reached the focus, image. So are you able to judge that this triangle is going to be the image of that rectangular strip? If you keep that rectangular strip as the object, what is the shape of the image you will get? This triangle shape. It will reach till infinity. If you choose a part of it, let's say if you say that, okay sir, my object was actually not going to infinity, it was till this portion only. So this is my object. Now tell me about the image. Okay, then because this is touching focus, your object will start from infinity and it will reach to some point. All right, so now the shape would be trapezium. If you say that, okay sir, let's consider an object till this point only. So let's consider this as the object. Okay, now because your object is not touching the focus, the image will also not be at infinity, it will be before that. So now you can say that your shape would be trapezium, depending upon like where the object is located. So like this you are able to answer these questions, guys. Okay, so very important thing. Now the same thing we can do for convex mirror also. So let's do that quickly. Okay, and the same approach is going to be there with lenses. Of course the points will change. Okay, so let's look at let's have a look at convex mirror. So in case of convex mirror, okay, this will be your mirror. This is the side we polish with silver polish. This is, let's say, focus, and the center of curvature will probably be somewhere here. This will become the pole, and I will do the same thing. Let me first draw an object line. So this is my object line. The head of the object is going to be there. After reflection, the ray will go like this, somewhat like this. Okay, so this is going to be my image line. Okay, this is going to be my image line, and let's do that. So I made the object in which color? Yellow color. Okay, so again, yellow color will be my object. So when my object is at infinity, okay, when my object is at infinity, then the image is formed at focus, highly diminished small image, and as the object is traveling rightward, the image will travel leftward, and they are supposed to meet at pole. Okay, so as the object kept on traveling rightward, the image will continuously travel leftward. Okay, the head of the image needs to be on the blue line. So you can see that these are the possibilities. So as the object reaches the pole, the image will also reach the pole. So what can I say now? And you see that we have considered all the possibility of real object. So any real object will be kept anywhere in this region. And if the object is kept anywhere in this region, we get an image between pole and focus. The image is an erect image, it is a virtual image, it is diminished in size. Okay, so I found everything about the image that we can get of a real object using a convex mirror. Okay, so now if I am willing to consider a virtual object, then what are my possibilities? So if I am willing to consider a virtual object, let's continue doing whatever we are doing. So as I shift the object from pole to focus, that means rightward, the image will continue to shift leftward. Now you see we are having a real image. Okay, and as the object will reach the focus, in that duration, the image has to reach infinity. So the image will continue its leftward journey. It has to travel leftward because the object is going rightward. It will continue its leftward journey and it will reach infinity. So when the object reaches focus, image reaches minus infinity. Now if the object travels rightward, the image has to still travel leftward. But how does it do that? Because it is already at minus infinity. So it comes from the other side. It switches the side. It switches over to the other side and it starts coming from here. So when the object is traveling between focus and center of curvature, the image will travel from plus infinity to center of curvature. Remember, their rendezvous is going to be is scheduled at center of curvature. So as the object travels towards center of curvature, the image also travels from towards center of curvature from infinity. Okay, you can continue this. As the object travels further right, the image will travel further left, and by the time object reaches infinity, the image must reach focus. So see, we have considered all that is there to be considered. All the possibilities we have taken care of, and that's how you do it. Alright, people, if you are able to imagine this video, then the tables that you learned in your 9th and 10th grade, that you learned that table, that if the object is here, the location of the image, the nature of the image, the size of the image, orientation, all those things you don't need to learn. You have all that in front of you when you imagine this video. Okay, so that was about mirrors. Now what if we want to do the same thing for lenses? Okay, so let's talk about the important points that we need to keep in mind in case of lenses. Okay, so what are the important points? Okay, let's start with the simple ones, the ones that you already know. So first one, if object is at, let's say, minus infinity, that means if it's a real object, okay, image is formed at second focus, which is also called as the principal focus, guys. Keep this in mind that for a lens there are two foci or two focus. Okay, so when the object is at minus infinity, the image that we get that is at the second focus of the lens. Okay, so for case of a convex lens, if the rays are coming from left to right, then second focus is this point, which we call as the principal focus. For a concave lens, this point is the second focus. Okay, the distance of first focus and second focus is same for a lens if the medium on both sides of the lens is same, but we have to be very clear that the image is formed at second focus when the object is at infinity, minus infinity. Okay, so that is point number one. Next point that you need to remember is if object is at 2f1. So 2f1 means twice the distance of focal length, but on at f1. Okay, it's at, then image is at 2f2. For this, I would certainly draw the diagram to help you understand what is this point. If object is at 2f1, the image is at 2f2. So let's say this is the convex lens. So in case of a convex lens, all right, we will assume that the rays are coming from the left side. Okay, so this point would be f2 and double distance. You know, this is f2, this is f2. So let's call it as 2f2. This point is, let's say, f1. So this distance is same as this distance. Okay, and this is 2f1. So this distance is same as this distance. Now, what this point suggests is this, that if the object is here, then the image will be here. This is what we are suggesting in this. Let's now, for case of convex lens, it was actually pretty simple to understand. Students generally struggle with this point when they think about a concave lens. So let me do it for a concave lens. Okay, so this is a concave lens. This is the axis. Now pay attention, pay careful attention, bachcho. Here, this point is f2. Remember, a parallel beam will tend to pass through f2 after refraction. So f2 is the second focus, and f2 is this point. f1 would be here and 2f1 would be here. So when I said that keep the object at f1, does it mean that I keep a bulb here and then I expect to get the image at f2? No. If I keep a bulb here and the rays goes like this, then the image will form somewhere here, not at 2f2. So this is not what I meant when I say that keep the object as at 2f1. In fact, if the rays are going from this side, then this is no more 2f1. This becomes f2 now. All right. Keep that in mind, that I assume that the ray is actually coming from the other side. What happened? So ray can't come from this side. Ray has to come from left side. Only therefore we are calling this point as f2, because ray is coming from that side. So if the ray is coming from left and if the object is at 2f1, how is that possible? We are talking about a virtual object. It's actually very simple. We are talking about a virtual object. So this is what we are talking about. Okay, so this is the object, and then after refraction, this is how the rays goes. Got it? So now you understand, object is at 2f1 and image is formed as 2f2. So this is the point. Okay, these diagrams will help you to keep this point in mind. So that was the second point. Third point, where does the object and image meet in case of a lens? Okay, so object and image meet only at optical center. In case of lens, there is only one meeting point, and that meeting point is at optical center. Okay, so keep that in mind. Next point, if object is at f1, okay, if object is at f1, image is at plus infinity. Let's check this. So if this is my lens, okay, if this is my lens, this is principal axis or optical axis, rays are coming from left side. So this point will be f1. So if I keep an object at f1, I know you are familiar with this ray diagram. So rays going like this, they become parallel like this. So the image is forming at plus infinity. Now let's consider the case of concave lens also. So for concave lens, remember this point is f1. So if I'm saying that object is at f1 and rays are coming from the left side, so this is what I'm talking about. So rays are coming like this, okay, and then they will diverge to become parallel, and the image will be formed as plus infinity. So this is the situation. Okay, now guys, you might be thinking that, sir, why with so many points in case of lens? In case of mirror, there are hardly 3 points. Now we have already written 4. Are we going to write more? Let's see. We need one more. Very essential points we have not written yet. I'm writing more points to make it easier for you to understand what will happen. See, the more points you are aware of, the better video you can make in your mind, because there will be more checkpoints to confirm whether you are thinking in the right direction or not. All right. So do we need all this to make the video? No. How do they help? They give you more checkpoints to ensure that your thinking is not going in the wrong direction. Okay. Final point. Let's not write any more, but only one more point. That is actually essential. In case of lens, VI parallel is given as this. So in this case, we can conclude that object and image, that they have the same direction. The object and the image, they travel in the same direction in case of a lens. All right, people. So we are now in a position to begin. Let's begin with convex lenses. Okay, let's begin with convex lenses. So this is my lens. I should have drawn the optical axis first. This is my optical axis. Okay, let me mark the points. Let's say this is f2, so this is 2f2. Let's say this is f1, so this is 2f1. Okay, let me mark the object line. So this is my object line. The head of the object is going to be on this line, and this line after refraction will pass through f2. All right, so this line is my image line. Okay, let's begin now. Again, object in yellow color, image in red color. Object is at minus infinity. When it was at minus infinity, the image was forming at f2, and they need to have the same direction. So when I started moving the object from minus infinity towards right, I've started moving the object towards right, the image will also move towards right, and it will start its journey from f2. All right, and keep in mind, by the time object reaches to f1, the image has to reach to f2. So all the while when object is moving from infinity to f1, the image will move from f2 to f2. All right, this distance will be same as this distance. It may not appear like that in my figure. I'm not sure whether it's appearing like that or not, but it has to be same. Because these distances are equal, so size will also be equal. Now, if the object continues its rightward journey, the image will continue its rightward journey. By the time object reaches f1, okay, by the time object reaches f1, the image should reach plus infinity. All right, the image should reach plus infinity. So you can see this is what will happen. Okay, now if the object crosses f1, the image must travel rightward, but it is already at plus infinity. Where will it go now? So as was in the case of mirror, it will switch over to minus infinity and then begin its rightward journey from there. All right, so as object travels from f1 to the pole to the optical center, let's call this as the image will come from minus infinity towards right. The object is traveling rightward, the image will travel rightward, and they are going to meet at the optical center. So it is here they meet. That now we have considered all the possibilities of image for a real object. You know, real object can only be in this part of the universe. So we have considered all the possibilities of image formation by a real object. Okay. Now, if we are willing to consider the virtual object case also, let's continue then. Nothing different. Object continues its rightward journey, the image will also continue its rightward journey. As the object travels from optical center to infinity, okay, the image will travel from optical center to the focus, because when image shifts to infinity, when object when the object shifts to infinity, the image will shift to f2. All right, so this is the case. I hope we are very clear with everything that we have discussed here. All right, people. Okay, so this is the case of convex. Same way we can do the case of concave lens also. Let's do it very quickly. Okay, so for the case of concave lens, okay, for the case of concave lens, what do we have? This is the optical axis. Then this is the lens. Let's say this point will become f1. This is 2f1. This point will become f2. This is 2f2. Okay, let me draw the object line. So this is the object line. Okay, this ray after refraction will pass through f2. So this will become my image line. Okay, this will become my image line. And then the usual stuff. Object is at minus infinity. Image will be at f2. Object is traveling rightward. The image will also travel rightward. Okay. By the time object reaches to f1, so when object was at 2, okay, this was 2f2, guys. I wrote this incorrect. This is f2 actually. Yeah, that was a bit confusing for me. Now everything is okay. So as the object is traveling, okay, as the object is traveling rightwards, image will continue to travel. We did not write any point regarding what happens when the object is at 2f2. We did not write any point. Keep that in mind. You can check the 5 points. All right. So when the object is at 2f2, nothing significant happens. Like it's a usual case. So the image keeps on traveling rightward. So this is the image we get. Okay, and they are going to meet at the optical center. So all during this while. So the entire case of a real object is covered. We will get a virtual image which is diminished in size, which will be located between f2 and the optical center, which will be erect. So these are the properties for a real object. Now, if we are willing to consider the case of virtual object as well. You can consider, you can keep on moving the object right. The image will keep on moving rightward. They need to have the same direction. As the object moves towards F1, the image needs to move to infinity. So as we are moving the object towards F1, image is traveling faster now because it has to cover infinite distance. And by the time object reaches F1, image has reached to plus infinity. Okay. Now, if the object continues its rightward journey, image will start from minus infinity because it has to travel rightward. So it will start from minus infinity. So as we shift the object towards 2f1, the image shifts from minus infinity towards 2f2. And keep in mind, when the object reaches 2f1, we wrote this as one of the point. When the object is at 2f1, image is at 2f2. So image will reach here. All right, image. Oh, I drew it at the wrong place. The image will reach here. Okay, and then if the object further continues its rightward journey, the image will also continue its rightward journey, and by the time object reaches infinity, image will reach at f2. So that is all the possibility for a concave lens, and you can make that table, and that should be it. So guys, I hope you will practice this twice or thrice. That should be enough, and then you will become comfortable with. You don't have to remember those tables, that you are made to remember in your schools in grade 9 or 10. You can think about this and you can make that table instantly if you need those tables. All right, and you will not need those tables. If you are able to imagine these videos in your head, you will be able to answer all the questions very easily. On that note, I will end this session here today, and I hope this concept was able to help you. It will help you. It will surely help you. So practice this concept. I'll come back with more videos, more concepts. Take care, everyone. Bye-bye.